Okay, let's start with the introduction to Java. Java was first developed by Sun Microsystems by the James Gosling, and the first version was Java 1, which came up in 1995. And the original name of Java was Oak, and due to some naming issues, later it was renamed as Java. The most powerful thing about the Java that it is written with the purpose of Fora, that is write once run anywhere. So Java is a powerful language. You can write the program on any platform and you can run it on any platform. How does it work? That it is so flexible that will do in the architecture of the Java. Over the time lot of versions came up for the Java, and I hope you all are familiar with the latest version like Java 5 or Java 6, and you might have worked on that. We are going to do Java 7, and Java 8 has just got introduced, right? Industry is still working on Java 6 and 5, mostly on 6. So we'll be doing Java 7 in our sessions. So there are various editions of Java available. We have Java Standard Edition, that is used for software development. We have Java Enterprise Editions, which is used for the web development. We have Java Micro Edition, which is used for mobile application development, and Java Cards for smart card application development. So we are going to do Java Standard Edition and Java Enterprise Edition, and then we will move towards the frameworks. So I would like to show you uh, the course contents of Java, what we are going to cover. So we are going to cover the course. First of all, the course is for the 6 weeks, right, including the project and interview preparation. It is flexible. If we are able to cover it in 5 weeks, we can. If we need one more week, we can. It's flexible. The class will be Monday to Thursday or Monday to Friday according to the topic we'll be doing. It will be for 2 hours. That is more than enough, right? So first of all, we'll be covering with the core Java, and we have all these topics in the core Java in which we are going to do the basics, Eclipse, modifiers, structures, strings, arrays, methods, all the OOPS implementations, regular expressions, utility classes. So these are the core concepts of Java which we are going to cover. Then we have advanced course contents in which will be covering about the Java exceptions, IO, database connectivity, JDBC, multi-threading, collections, generics, nested classes, serialization, data structures, legacy classes, just the introduction about it. We'll be covering with reflection, assertions and annotations. So a lot of advanced topics we'll be covering within Java. Then we'll be moving towards the Java Enterprise Edition. There we'll write the server-side programs using servlets, JSPs. We'll use JSTL and we'll work on Java Beans as well. Then we'll go ahead and we'll do Struts 2, a framework, right? So framework, for all those who are doing it for the first time, framework is a collection of libraries which makes our work more efficient and flexible, right? So frameworks are very much in the industry. So we'll be doing Struts 2. After that we'll be doing Spring 3, and after Spring we'll be moving towards Hibernate. We'll be covering Hibernate as well. These are the 3 main frameworks which are actually very much in demand in the industry. And along side by side we'll be working on these topics also, which are the supporting tools like HTML and JavaScript, MySQL, Log4j, JUnit, EJB. I will be working on Java design patterns. We'll be understanding the design patterns. I'll be introducing you to how to create the SOAP web service and the REST web service. I hope you all must have heard, because you all have worked about the web services and how much they are in. And we'll be going ahead with the combination of XML and Java, and that is JAXP, and JAXP also will do. It might be technical terms for you now, but these are the course contents. Then we'll moving towards, I'll be giving you one project to develop, the web project, will have interview preparation. I'll be giving you the links and I'll be guiding you for that. And then we will have mock interviews. So this work we have to do in the course curriculum.
Jayanti, I'm sorry to interrupt you, but JAX-B is similar to Ajax or something?
No. Ajax is different. Ajax-B is a Java and XML binding.
Okay.
It's not Ajax. Ajax can be in
Okay.
this course. That is for front-end technologies.
Okay. Okay.
Okay. So that was the introduction about the course, what we are going to cover. So I'll just introduce about the OOPS programming, and it will be really good if you all can interact with me if you're not getting. What is OOPS programming? OOPS stands for Object Oriented Programming System. It is a structure on which Java is based. So Java is Object Oriented Programming Language, and it is based on classes and objects. So the features of OOPS are, we'll be just going through each of the feature of the OOPS. The features are class or object, class and object, abstraction, encapsulation, inheritance, and polymorphism. So all the languages which are actually saying that we are OOPS languages, we are OOPS oriented, object oriented programming languages, then they must have these features in them. So first of all, what is a class? If you have to define a class, what is a class? So class is a blueprint, or it is a basic architecture or a skeleton, and it does not exist physically. Class never exists physically. It's because it is a structure, it is a skeleton. So if we talk about class, furniture is a class, car is a class, animal is a class, but these classes are only structure. Human is a class, it's only a structure. They don't exist physically. What exists physically are their objects. Like furniture class has the object table, chair, bed. So table, chair, bed, they exist physically. They are objects which are actually taking the architecture of the furniture. Car is a class, Maruti, Honda, Hyundai, etc. Animal is a class, cat, dog, tiger are objects. So it's very important to understand about object and classes, because Java is pure object-oriented language. It's 99% object-oriented language, and it's very important. Everything in Java is an object except its 8 data types, 8 primitive data types, which we'll be discussing. So what is an object? If you have to define object, what is an object? Object is an identifiable entity. Any entity which has its own identity, which has its own attributes and behavior. That's what object is. And object exists physically. You, me, we all are objects. We all have our own identity. We all have our own properties, attributes, and we all have our own behavior. And we all belong to human class, right? So objects are always identifiable entity. So all those languages which implements OOPS, they are known to be as very much close to the real world. How are they close to the real world? Because the way we interact with each other to accomplish some task in the programming language, objects also interact with each other through messages to perform some task, to accomplish some task. So it's exactly the way we are trying to have a class right now. I am interacting with you, you are interacting with me. We all are objects interacting with each other. So same way, the Java objects or any language objects interact with each other to accomplish that task. So it's a class furniture, and we have the objects table, chair, sofa, bed, and we have the attributes wood, color, brown, and behavior is to use to keep the things. Then we come to the most important feature, abstraction. So abstraction means user's perspective. What is user required with? So basically the definition of abstraction is concentrating on essential things without looking into the background details. So take an example, we have the switchboard, and as a user we just need to know how to use this switchboard. We are not concentrated how background wiring is done. It's not our job to look into that, how is it working. So about the user's perspective is abstraction. Whatever is required, concentrate on that. Looking into the another example, we have the person asking for the information from the information window. His concern is only to get the information. How that information got collected for him, it's not his concern at all. So every time when we talk about the user's perspective, that means concentrating on essential things without getting into the background details, without getting into the implementation of anything. This is what abstraction is. So these features what we are discussing right now in OOPS, we are going to implement everything in Java using the Java programming. Then we have the encapsulation. Encapsulation is wrapping up of data into single unit. So what do I mean by that? Wrapping up of data into single unit. By that I mean, first of all, encapsulation means data hiding. You are hiding your data. So where are you hiding? The implementation part. Continuing with the same example, the implementation part is encapsulation, because that is the place where all your data resides and it has to be secure. So you have to wrap up. Wrap up means you have to make it this way that no one can access it without the permissions, right? Or it should not be directly available to everyone. So because business logic lies in the implementation part. So whenever we talk about the encapsulation, we talk about the implementation part, and encapsulation leads to abstraction and abstraction leads to encapsulation. Okay. Then we have inheritance. Inheritance means simply reusability of code. Whenever we want to have the reusability of code, suppose as an example, we have bicycle class over here and we want to have three other classes which will be inheriting some features of this bicycle class, maybe the skeleton of it, structure of it. So we will inherit, we'll provide inheritance, and the way we all inherit from our ancestors, same way we'll have the parent class and we'll have the child class, and we can always reuse the features available in the parent class into the child class. So reusability of code wherever is required is actually for its implementing inheritance. Now we'll come to the most important topic. Any language which is declaring itself as the OOPS language must have polymorphism in it. It's a key feature. So poly means many, morphism means forms. So performing one task with different forms is polymorphism. So whenever we want to perform one task with different forms, it's polymorphism. A simple example, I ask you all to introduce yourself, right? You all did the task of introduction but with the different forms. Your way of introducing yourself was different, right? So this is what polymorphism is. We are achieving the same task with different forms. I asked you to draw something. One person can draw a rectangle, other person can draw ellipse, third person can draw triangle, but you all are performing the task of drawing. So polymorphism is doing one task while implementing different forms, right? Am I clear till this point? Please keep communicating with me on chat window.
Yeah, Jayanti, one thing about the abstraction and encapsulation. So, did you say like encapsulation leads to abstraction and abstraction leads to encapsulation?
Yes, I said that.
So what exactly you meant by that?
By that if we are encapsulating anything, that simply means user will get only whatever the essential things are, right? So
Okay.
it is leading to abstraction. And if we are working on abstraction, user will never get to know what is happening in the background. So that is leading to encapsulation,
Okay.
right?
Okay.
Okay, continuing with the features of Java, that why Java is used. There are a lot of features of Java: simple, object-oriented, robust, multi-threaded, architecture neutral, interpreted and compiled, distributed, dynamic, and secure. I'll be discussing one by one. As you, most of you are from the Java background, so you might be knowing a lot of things in this. Uh, Java is simple because it contains many features of the other languages like C and C++, and definitely it removes the complexity, and the most important complexity which it has removed is pointers. It has removed pointers and it has removed the deallocation of memory. That is all done by automatically in Java. Or whatever we used to do in C, C++, allocate the memory, deallocate the memory. Now the programmer has to only allocate the memory. Deallocation work is done by the compiler itself. How does it do? That we'll discuss in Java architecture. Java is OOPS language. We have objects over here, and objects interact with each other too by passing messages to perform a task. Java is a robust language. Can any one of you tell me that why Java is a robust language? Robust means powerful. So what is making Java a powerful language?
Because Java is platform independent. It can be run on any platform.
Yeah. What else? That is the Vora feature, that write once run anywhere. That is a feature that it is architecture neutral, right? So thanks about that. Java is a robust language. It's important interview question also, that why Java is powerful language. Because of its strong memory allocation system. The programmer is only worried about allocating the memory, and rest, deallocation of memory, will be taken care by automatic garbage collection mechanism. And this is a mechanism which you have to remember right now, and we'll be doing it in detail, that how does it work internally when we'll go ahead in the architecture of Java, that how garbage collector works, and it wipes off unwanted objects and it provides memory for the other objects. It has a lot of other things also. Powerful exception handling techniques are there. So the program should not interrupt abruptly and come out of it, and user will keep on sitting, oh, what has happened with me? So Java provides us with a very good exception handling techniques where we can handle such situations by writing code in very efficient way, that yes, we can make it more user friendly, right? And a lot of compile time checkings are there that we'll see how we work when we'll do coding. Just give me a second. Java is multi-threaded. Multi-threaded means, what is a thread? Can anyone of you tell me what is a thread?
A thread is a lightweight process for running a particular object.
Yeah, thread is a lightweight process for running a particular object. So nowadays, where are threads getting implemented? Can you give me any example about it?
Uh, like a thread that is used to run a calculator or a notepad.
Okay. Okay, thanks. I'll give you the example. Multi-threaded threading is a very important topic to discuss about. Uh, Multi-threading is very vast also. If you go in detail of multi-threading, it will just not end up for 6 months also, right? So multi-threading I'll just introduce right now because we'll be doing it in detail in our course. So it's actually lightweight processes, that means which are running simultaneously at one time. Best example could be your web browser. You open one web browsers and you have multiple tabs running at some same time. The other example could be when you are playing any game, you are inputting lot of things. You are driving a car, you are pushing something, you are hitting something. So lot of threads are working concurrently with each other, right? To accomplish your game, to perform your game. So multi-threading means that nowadays you have smartphones. In smartphones you get message from one number, and then that message keeps on getting added within the same process, right? So multiple threads are getting created. You have a conversation like of a thing, whereas it used to be earlier like for every time you used to have separate memory allocation. So these are few very basic examples I'm telling you about multi-threading. So We'll be doing multi-threading in detail. So right now you just need to remember that it's just running multiple light processes at same time concurrently. Then we come to architecture neutral. By architecture neutral we means Java is platform independent language. It provides us with the feature of write once, run anywhere. That means we can write a code using any kind of processor, any kind of OS, and without giving us any compatibility issue, it will go and execute anywhere on any other platform. So Java is it's a key feature of Java that makes it different from other languages, and that is the reason that Java is the best suitable language for internet, because on internet you don't know where your program is going to execute on what kind of platform, so you should not have any compatibility issue. So that what Java provides us with. It's platform independent language. Java is both interpreted and compiled. So what is compilation? What is compilation?
Converting from source code to machine code.
Yes, absolutely correct. Converting from source code to machine code. Compilation means in C, C++ we used to write the file and we used to have the compiled version in machine language. The exact copy in the machine language which the compiler used to read and then give us the errors in our own file. So till now either the languages were compiled or interpreted. So what is interpreted? If any one of you have worked on Visual Basic, you might be knowing that while typing, it gives you error then and there only. It won't let you type further if you're typing something wrong. Interpreted means while typing it will keep on checking. So as an application nowadays, Microsoft Word is interpreted because when you type something wrong, it marks you red line there. If you have some space issues, it gives you a green line. So it is doing interpretation when you are typing. So if you're talking about languages, before Java, everything was either, all the languages were either compiled or interpreted. But Java is a language which is both interpreted and compiled. And how it is both interpreted and compiled, that we'll know in the architecture of Java, how it is working, where the compilation phase is working, where the interpretation phase is going. That we'll all discuss in the architecture. Java is a distributed language. What do I mean by distributed language? By distributed language, I mean always distributed means it can be used on the networks. So Java provides us with such libraries that we can write the programs for networks. We can create the servers, we can create the clients, we can make client and server interact with each other. But we do not have that thing in our course because that is for the networking in Java. That is a little bit separate line to go for. That we can introduce if we get the time in between, but specifically we are not going ahead with that. The most famous protocol that we all use, HTTP, is written in Java, right? Same way we have lots of things written in Java which are very famous in market for networking purpose. So it provides us very strong libraries for networking. Java is dynamic. Can anyone explain me what do you mean by dynamic? Dynamic means always runtime. Whenever dynamic word comes, it means runtime. So all those who have already worked on Java, you might be knowing that if you do not have any libraries with you and you are trying to execute any Java programs, what happens at that time? What happens at that time? Does it give you DLL missing or something? It will never give you errors like DLL missing or something because Java is designed to adapt the evolving environment. That means Java is so flexible that if it is connected to internet or it has its own environment in which it runs actually. So it is so flexible that it will search for the libraries and it can freely add the required libraries for its execution. How does it do? That will do it in the programming, but it is a dynamic language which will never interrupt that library is not available. Either it will fetch the library from its working environment or from the internet, wherever the path is available. It is able to do that during runtime. So whenever the word dynamic comes, it always talks about the runtime. Then we have the last feature, that is security. So security, Java is a secure language. First of all, we do not have any memory pointers. Pointers are eliminated in Java. Programs run inside the virtual machine. Java runs inside its own environment, that is Java virtual machine, which is known as the sandbox of Java. It doesn't come out of that. So when it doesn't come out of that, what happens in that case? When it runs in JVM, it is not able to access your hard drive. So there is a security manager inside Java which keeps a track that reading and writing to the local disk should be limited or should not be there, right? What resource should be available? Hello? Can't you hear me? Hello? Who can hear me and who cannot hear me? Aditya, hi Aditya, you can hear me. Sorry, none of you can. Only Aditya can hear me. What happened? Can you hear me now? Aditya is able to hear me, but none of you can hear me.